Welcome back, Playbasic Coders. Here's revision 4 of the Wolf 3D demo. Just added a few extra things. We've got some backface clipping for the walls and the environment, walls and floors, and mostly what we've added is a texture library with MIP mapping. Let's have a look at it to explain what MIP mapping is. Let's find an object. There we go. See how it's changing, appears to be changing color. Now, each object has 4 different versions of the texture, and I've pre-colored them so we can see if our routine's working correctly. And so what it does is it works out how far away the object is, and then chooses the appropriate texture resolution based on how far away it is. The further away it is, the lower the texture resolution. And I've added a color to these two to make them so they stand out as we move away from them. And what that does for us really is it makes rendering of each object much cheaper. The cost of drawing each polygon in each dragon is less, particularly as they're further away from the camera. So when we have a scene that has more of these in it, we don't experience the same trough that we did before. Now what I should note is that none of the other objects in the scene are like this. The floors don't have MIP maps and the walls don't, which is an obvious upgrade, isn't it? So stuff down here that's much further away and these other walls here don't really need to be the same resolution as what the ones up near the camera do need to be. It's a very common technique and pretty easy to add. The main change really is this textures library where it's just has an array where we have a load texture. This loads in an image for us, a normal PB image. We are just talking about Playbasic 165 here. Get the width and height of this thing. We store that as our texture, and then we have a choice when we load the texture. Do we want to have MIP levels? Now, each MIP level is the previous size of the image divided by 2. So if it started out 128 by 128, the next MIP level down would be the same image scaled down to 64 by 64. The level 2 of the MIP would take that 64 by 64 image and scale it down to 32, and so on, which is what it's doing down the bottom here. And I'm just adding these colors on top of that so we can see something interesting. We just turn that off and run it again. The objects will appear pretty much the same as normal. Now, because I'm using a routine that's kind of doing the average of the pixels, it does tend to fade out colors as they scale the image down. But as you can see, we're pretty much, you don't really notice. Like the levels are close enough, you're not really noticing. But the performance is pretty much staying pretty much on par. So we haven't even got to adding things like portals to it. Sorry, we just changed the walls to this mode, to light map mode. That's just the filled color version. There we go. So it just helps out for rendering. That's all it does. It just makes those polygons easier to render for the processor. It doesn't matter whether it's the processor or the GPU. If it has to read, drawing a small polygon from a big texture is expensive because the memory access as we're trying to fetch those textiles, which is what we call pixels in texture space, is slow because we're getting all these cache misses. It's much more efficient on the machine to have us read memory that's it's more packed, more localized to each other. So objects are far away, using a small texture means we don't experience as many downgrades of performance. I'm pretty happy with that, given we're capturing as well. The capture knocks off about probably a good 10 to 15 frames on my laptop here. So yeah, yeah, given that most people wouldn't have thought this was possible in PV, it's pretty good. Okay, thanks for watching, and we'll see you next time. Bye.